Hi everyone. So in the last module of string analysis in static analysis, and in the string analysis we have seen some basic string analysis, how we can identify the basic strings in a particular malicious file, and we have extract the same and we did some findings, right? So with the help of run persistent key, the file may get persisted in the particular system when it is get rebooted, and some basics 64 encoding algorithm related strings is actually present in that particular file, and some the file, we can confirm that file is actually a DDoS capable file, denial of service capable of file, because some strings related to the DDoS is actually present. So similar things we have been finding out in the last module. Today in this module I'm going to tell about so three things, right? Packed strings, random strings, and encrypted strings. So what is meant by packed strings? As I said earlier, the file, the malicious file may be a packed or unpacked file. So some malicious author will use some malicious packing technique, and with the help of that particular packing technique or some packing tools, they will actually packed that file so that the malware analyst couldn't read actually what is present in that particular malicious file. So the left hand side we can see packers and strings. So here the left hand side is an unpacked file which shows the clear readable format of the strings, but here in the packed format of a particular malicious file we couldn't see the readable format of that strings. So if the so what I am confirming here is, if my file, malicious file, is packed, then I couldn't read the strings which is present in that particular malicious file. If it is unpacked, if it is packed, then I have to go for some unpacking algorithm or unpacking tools, and I am unpacking that the same file. I am here clearly seeing the strings which is present in that particular malicious file. So, and then the third thing is random strings. So packers sometimes may add some random or legitimate looking strings to trick the malware analyst, right? So that may also be possible. So that is called actually random strings, or unusual strings, some padded strings we can call it as, right? So this is called actually random strings. So packers sometimes may add some legitimate looking strings to trick the malware analyst. And then last one is actually encrypted strings. So this is a very important thing. We are going to see a demo here with the help of this thing, concept, encrypted strings. Strings may be encoded or encrypted. Some strings may be encoded. Some strings in a malicious file may be encoded or may be encrypted with the help of some algorithm and all. And we couldn't, it looks like a random strings. If it is being encoded, if a particular readable formatted string is being encoded with some algorithm, as a malware analyst, I couldn't read that particular string. So I have to go for some decoding techniques, and we have to decode the same, and then we have to understand what actually the string is. So the first algorithm we are going to see here is the Base64 encoding algorithm. Here this will convert the 3 bytes of data to 4 characters, 4 ASCII characters, right? 4 ASCII characters. So this is the basic thing about Base64 encoding algorithm. The symbols which is present used for encoding a particular string is capital A to Z, small a to Z, 0 to 9, and a plus sign and a slash symbol is used for encoding technique, or the default characters used for encoding technique. Strings may be padded to the length of 4 with equal symbols. Why this is happening here in this Base64 encoding algorithm, I will tell you. So all Base64 encoding strings must be of length divisible by 4. So if a string has been encoded with the help of Base64 encoding algorithm, then the encoded strings must be length which is divisible by 4, right? So in the event, if an encoded string doesn't meet this requirement, if it is not divisible by 4, the algorithm will add 1 or 2 equal signs. So if I am having the encoded strings with a length of 15, then it is not divisible by 4, right? Then I have to add one equal sign so that it will satisfy the protocol of that particular algorithm, right? So we have to add one or two equal signs to satisfy the protocol of that particular Base64 encoding algorithm. If I am seeing two equal signs or one equal signs at the end of a string, then immediately we can think that this string may be encoded with the Base64 encoding algorithm. Here we can see an example. Hello world exclamatory mark. It has been passed through this Base64 encoding algorithm. I am getting this result, encoded strings. It looks like a random strings. If it has been encoded, it is in the unreadable format. So hello world is actually a readable format. Maybe we can call this as a plain text, and this may be the algorithm, Base64 algorithm, getting the ciphertext. So this is the concept actually here. So hello world with end with the exclamatory mark. When it is passed through this Base64 encoding algorithm, getting these strings. Can we count this thing? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it is a length of 16. It is actually divisible by 4. When I am removing this exclamatory mark, I'm passing it to the Base64. I'm getting this result. Why I'm having it has been padded with the equal sign? Because it is originally with the length of 15, which is not divisible by 4, and hence I am adding here in the last string as a equal sign to satisfy the protocol of this Base64 encoding algorithm. Now you count this thing, it is actually 16, which is actually divisible by 4, and hence I am satisfying the protocol of this Base64 encoding algorithm. So this is how most of the malicious authors use this Base64 encoding algorithm for encoding the strings which is actually present in the malicious file. So detecting the Base64 encoding algorithm, as I said earlier, we have seen these strings also, capital letter A to Z and small alphabetical letters A to Z, starting with numerical number 0 to 9 plus and slash symbol. If this string is present in any of your file, then that some of the files which is present in that particular malicious file may be encoded with Base64 encoding algorithm. So after encoding, it should be present here in this, like this, random ASCII strings that end with double hash or double equals or single equals. So this may be an encoded strings which has been encoded with the help of Base64 encoding algorithm. So this is how you have to find whether it has been encoded with the Base64 encoding algorithm. I am purely talking about the strings which is present in that particular malicious file, right? If I am seeing these strings, then I may confirm that some of the strings which is present in that particular malicious file may be encoded with the Base64 encoding algorithm, right? The second encoding algorithm is XR encoding algorithm. We all know, right? XR is 0, 0 means it is a 0, 0, 1 is 1, if it is 1, 0 is 1, if it is with the same symbol, it is actually 0. Coming to the cybersecurity terminologies, A is my plain text, with the key I am XORing, I am getting C. And reversibly, C with the XORing with the key, I am getting my A. If it is A XORing 0, I am getting A. A with the same A, I am getting 0. So here we can see here with an example, I am taking the word explorer dot end with the dot, and here representing with the hexadecimal format 45, 78, 70 or respective hexadecimal symbol. I am taking here the key as a 65 and XORing all the letters which is present in here in the explorer dot. I am XORing 45 XORing with 65, I am getting 20, 78 XORing with 65, I am getting 1D, similarly 70 XORing with 65, I am getting 1.5. Here there is an interesting case. If I am XORing E, right, 65, XORing with 65 with 65, I am getting 0, 0. So if I am getting 0, 0 as an output, I came to know that, right, the key may be 65 or the letter, the original plain text may be 65. So we have to apply the reverse order to decode this type of encoding technique. You clearly seen here, right? So E has been represented with 65. If it is XORed with the key 65, I am getting 0, 0. What does this mean actually? the same letter, if I am same sign, if I am XRing, I am getting 0 0. Only if I am XRing with the same letter, same symbol, I am getting the 0 0 as an output, right? And hence we can decide that key and the plain text may be the same key. Okay, so here in the right hand side I am giving some hint for you, strings to search for. So using this XR encoding, we are having a demo in this session with this tool, with this keyword, this HTTP kernel create. You are going to search with the help of this XR search tool, and you are going to find out whether any strings which is present in that particular malicious file is encoded with XR encoding or not. Let us enter into the demo. So you can download XR search, right? I will share the link in this description of this YouTube video. Right, so this is XR search, my tool, and I am extracting here. So it is present here. I am dragging this exe file from that particular folder into the desktop, and this is my malicious file. It is a command line tool, and hence I am opening my command prompt. So opening my command prompt. Since all the files is present in desktop, my malicious file, and every tool is present in my desktop, I am getting into the desktop. So here I am giving the keyword XR search space. Here I am going to give my malicious file name. I'm copying my name, right, giving space. Now I am going to give the keywords. So what I said earlier, this HTTP kernel and create, I am going to give the keyword. So first time I am giving this. So a result came out here. It found that XORed some string in that HDFC statement.exe is XORed with 0 0, right, 0 0. And I am getting this result. This program cannot be run in DOS mode. So here I am getting this, which means that the same letter it has been XORed. So when I am getting into my PPT, slide, if it has been XORed, if say for example this dot is actually 0 0, it has been XORed with the 65, I am getting the same thing 65. So some strings which has been XORed with 0 0, I am getting the same strings. We can confirm that. So similarly, so this means that some string has been XORed with 0 0, I am getting this. So this here what I am typing is the ciphertext. Maybe we can call it as a ciphertext. So this is the result, encoded result. So I am doing here the reverse process. So this line means that some string which is present in this HDFC statement.exe, it has been XORed with 0 0, and it gives a result of this. So this is not actually our result. So we have to search for some other key also. Can we go for create? Right? Create. So everyone understood, right? So it has been every strings which is present in the HDFC statement.exe, it has been XORed with, I am here finding out the key, and the create is my ciphertext. So why it has been filtered out with all the create? Because I am giving here the create. So all the say for example some string is XORed with 0 0, at the position 2C418 I'm having the strings create file. So here also we are not getting our result here. Let us try for kernel. Kernel is my key. Yeah, here you can see some interesting thing. What it has been found is some string has been XORed with 20 if it has been XORed with 20, at the position of 31294, I am getting this kernel. So this is the meaning of this line. Some string is being XORed with 20, I am getting my result kernel, right? So when I am opening this file with the bin text and I am searching for the 31294 file position, where is, this is the file position, first column is my file position, 31294. Here 31294. So here at the position of 31294, the string I have been finding out here in the capital letter of kernel32.dll. So this is an encoded format. It has been encoded with the help of XR encoding algorithm, and it is in the encoded format, which is in the capital letter. I am here decoding it, which is actually in the smaller letter kernel.dll. So I am finding here the key for XR encoding algorithm. I am going to find out with the help of HTTP. Here also I am getting, right? Yeah, I am getting XR. It has been XORed with 20. I am having this HTTP. Ciphertext. So this is how we have to search whether the particular string in a particular malicious file has been encoded or not. If it has been encoded, we have to find out whether it has been a Base64 encoding or XR encoding. Most of the malicious users, 90 to 95% of malicious users are using these two kinds of algorithm for encoding the strings which is actually present in the malicious file. So better go for this. You take this as a glimpse of embedded string analysis, and you search some more in the internet, and you find much more results than me, and you get back to me after doing some good analysis. Okay, thank you all.